Hello, my name is Richard Osborn, and this is my final project submission for CpE302 and also my junior design competition submission. So I made a 16-bit processor and operating system for the Altera DE2 board. So the way this works is the board has two modes. One is programmer mode and one is run mode. So when this far left switches up, it's programmable, and when it's down, it's running in an infinite loop. So you can add instructions, you can preload instructions, or you can inject them using the switches on the bottom. So I created a custom 16-bit instruction set to manipulate the processor. And then the operating system is what helps it interface with the buttons, because the processor doesn't know anything about switches or displays or keys. The operating system is what helps abstract all the hardware. So right now it's in programmer mode. And I have a line number here, and then I have a instruction being read here, which is 0000. I have a pixel out on this segment, which is why the 0 looks funny. So there are preloaded instructions, and I can read through them using the keys. So if I press key 1, it will increment the line number. If I press key 2, it'll decrement the line counter. And key 0 will read, while it's held down, the current instruction that is held at that line number. So these are all the instructions that are currently in memory. It's not many for this demonstration. And then this key will will write code into memory at that line address. So right now the display is reading the instruction indicated by these 16 switches. So 16-bit processor, 16 switches. Each switch is a bit, and when I raise these up, it will write that value to the screen. So here's 6. So here's me flipping the switches, and that's the instruction. So you can write instructions into memory on the fly while the board is running. So I'll show you. I'll go into a little bit more detail, but let me tell you a little bit about the processor and the instruction set. So it has 8 general purpose registers, and it's RISC style. There is no assembler, so it's all written in binary and converted into hex. So it has 16 RISC style instructions and a few others. It has support for logic, branching, looping, functions, a stack. So it is fully Turing complete. And it's heavily inspired by MIPS, but there's some x86 and some z80 slipped in there as well. So this is the spreadsheet that I use to manage the instruction set. You have the opcodes, or the mnemonics on the left, the opcode, the register source 2, register destination, and here's a function selector, or you can load immediate values, which is how you like inject numbers. And it supports all the way down to to shifting and adding and jumping and system call, all the good stuff. And then I have a instruction decoder which parses the word and sets all the multiplexer selectors. Quick refresher, because there's going to be a lot of binary and hex. Group 4 binary digits together and convert that into a hex digit. So it's a 4-to-1 ratio of hex digits to binary, or 1 to 4. So this is an example code that I wrote, which it's very basic. It just displays the numbers 0 through 7 to the 7-segment displays. And I've preloaded these instructions into memory. So here's the instructions on the left. And then on the right is a GIF of me iterating through the instructions just to view them in memory. But preloaded instructions are cool, but this project was designed to do code injection. So let's do some code injection. So let's write some code to print the number 7 to the screen. So we're going to take the number 2, add it to number 5, and we're going to print that result to the farthest right 7-segment value. So to do that, we will load 2 into a register, 5 into another register, add those 2 registers together, store the result, which is 7, load the call code, and then perform a system call, request the operating system to do a system service. So over here on the board, I indeed have all these instructions already in memory. So here's load the number 2, load the number 5, add them together, and then do the system call, and then repeat ad infinitum. So if I run this, or I will run it by setting it, instead of programmer mode, I'll slid it down into run mode, and here we have the number 7 displayed to the screen. So it works. But that's not quite code injection. Let's change it on the fly. That's the crux of this project I wanted to do, was change code on the fly. So let's instead of doing 2 plus 5, let's do 2 plus 7, or we'll do 2 plus 8 to get A, or 10. So I need to change this instruction to be A1, 0, 8. So I will take these switches, A1, 0, 8, and then I will hit the inject button, or the save button, and then let's run it again, and boom, there we go. So 2 plus 8 is A, or 10 in hexadecimal. So, success! So thanks for paying attention to my presentation. I thought this was really cool because I'm a computer science major and I got to build my own processor from the ground up. And this was really, I got to learn a lot about like all the intricacies of how processors work and how hard it is to add new instructions and stuff. So thanks for listening.